Have you ever tried to learn coding and almost immediately felt like the people teaching it were deliberately trying to make it look way harder than it actually is?
Oh, absolutely. It is such a common experience.
Right. You sit down, you are highly motivated, maybe you've got your coffee ready,
Yep.
and right out of the gate, they just throw this massive wall of random text at you.
And their jargon, so much jargon right away.
Exactly. They start using intimidating jargon way too early, and you are just sitting there completely forced to memorize syntax before you have any, conceptual framework for what any of it actually means.
It's overwhelming.
It really is. It feels like they are actively trying to keep you out of some secret club.
It is an incredibly common wall to hit.
Right.
And honestly, looking through our source material today, it is the exact reason why so many beginners start their coding journey with a ton of enthusiasm. But, well, very few actually reach the point where they genuinely feel the logic of programming.
Yeah, they just give up.
Right, because it becomes this rote exercise in frustration and memorization rather than, an actual exercise in problem solving.
And that universal frustration is exactly why we are diving into this specific set of sources today. We are acting as your guides to unpack the introduction script for a very unique learning framework called Python Basic Syntax in 10 levels.
Which is a fantastic framework.
It really is. The overarching mission of this deep dive is to adopt the absolute warmest, most motivating energy of the best instructors out there and basically set you up for absolute success.
I love that.
We want to prove to you today that Python isn't magic. It isn't something reserved for math geniuses. It is a completely logical step-by-step journey from complete beginner to strong beginner.
And I think we need to establish right off the bat that the goal of the material we are exploring isn't just to help you figure out how to copy code from a screen.
Because anyone can do that.
Exactly. Anyone can copy and paste a script from a tutorial.
Mm.
The true goal here is to fundamentally change how you approach the concept of learning technical skills. This 10-level system is specifically designed to help you build the actual cognitive architecture, the mindset, really, of a real programmer.
Okay, so let's unpack this. Because before we can build the right way to learn Python, we really have to look at why the standard traditional methods fail so spectacularly for the average person.
They really do fail a lot of people.
They do. Why do people hit that brick wall on literally day two?
Well, the source material identifies two primary traps that standard beginner lessons always seem to fall into. First, they are often what the author calls too shallow.
Too shallow.
Yeah. Meaning you are taught how to type the code, you get the right output on your screen, but you have zero grasp of the underlying mechanics. You don't know why the computer did what it did.
You're just a typist.
Exactly. You're functioning as a typist, not a programmer.
It's like trying to learn to cook by blindly following a recipe step by step without actually knowing what the ingredients do.
That's a great analogy.
Like you don't know the chemical reaction salt is having with the meat, right? You just know the piece of paper set to sprinkle it on.
Exactly. And when the recipe goes wrong, you have no idea how to fix it because you don't understand the components.
You're just guessing.
Right. And then the second trap is the complete opposite. Courses make everything too complicated.
Oh, yeah. The overcomplicators.
They take incredibly simple, fundamental ideas
Mhm.
and explain them in such an overly technical, abstract way that the student feels completely lost before they have even had a chance to build an ounce of confidence.
So, to stick with that cooking analogy, that would be like walking into a kitchen on your very first day and being forced to memorize the complex molecular food chemistry of a Maillard reaction before you are even allowed to crack an egg.
Perfect. Yes.
Both of those methods, the shallow and the complicated, they just leave you hungry, frustrated, and totally confused.
And what this script emphasizes is that the 10-level system is built to dismantle both of those traps entirely.
Which is so refreshing.
It completely replaces random, disconnected lessons with a highly deliberate journey. It's about aiming for a stronger, real understanding of the mechanics rather than a superficial one, but without overwhelming you with computer science theory on day one.
Since random, chaotic learning clearly leads to overwhelm, the natural solution is to restructure how the brain actually receives the information. The source talks heavily about escaping the giant, messy block of traditional education.
Because coding is not something you can swallow whole.
No, definitely not.
The human brain just doesn't process abstract technical information effectively that way. The source details 4 crucial progressions of real learning. First, moving from simple to deeper.
Okay.
Second, from clear to practical. Third, transitioning from merely seeing code to actually understanding code. And fourth, the final leap, moving from understanding to writing your own code.
Here's where it gets really interesting to me, though. There is this one specific phrase from the source that just jumped off the page. It says, "You do not just watch information, you climb it."
You climb it. I love that phrasing.
There is such a massive difference between passively binge watching coding tutorials on your couch, like it's a Netflix show, and actively climbing a structured ladder where every single idea arrives at the exact right time.
The cognitive science behind that idea of climbing is actually fascinating. When you passively watch a 2-hour tutorial, you experience what psychologists call the illusion of competence.
Oh, I've definitely felt that.
We all have. You watch someone else write the code, it makes sense in the moment, and you think, got it. But your brain hasn't actually built the neural pathways to retrieve that information or apply it.
Yes. That awful feeling of closing the YouTube video, opening a blank document, and realizing your mind is just completely empty.
That happens because your brain experienced information overload without structural application.
Right.
But when you climb, meaning every level has a distinct conceptual purpose and builds precisely on the one before it do, your brain doesn't experience chaos. By the time you reach higher, more complex levels, you aren't overwhelmed because your brain has already done the heavy lifting of building the necessary foundation.
So now that we understand the underlying philosophy of climbing, let's actually map this out. I was looking through the 10 specific levels in the source, and instead of just reading them like a table of contents, it feels like they naturally group together into distinct phases of learning.
Yeah, that makes sense.
The first phase seems to be all about establishing a conversation with the computer.
I completely agree with that grouping. Level 1 starts with the absolute foundation, which is the print command.
Hmm.
This is simply how Python shows output on the screen.
Just getting it to talk.
Exactly. It is your first interaction getting the computer to talk back to you.
The classic hello world moment. You
Always.
tell it to say something and it says it. Psychologically, I think starting here is huge because it immediately proves you are in control. It removes the intimidation factor.
It really does.
But it's kind of a one-way street at first, right?
It is, which is why level 6 eventually introduces input.
Okay, jumping ahead a bit.
All right, just to connect the ideas. If print is the computer talking to you, input is how Python receives information from the user.
Yeah.
It makes the code interactive. But, before you can ask a user for input, you need somewhere to put that information.
Right, you need to store it.
And that brings us to the second phase of the journey, giving the computer a memory.
That's level 2, variables. And now, I always hear variables described as little boxes in the computer where you store things. You put a number in a box and write a name on it. Is that really the best way to think about it?
The docs metaphor is okay for absolute beginners, but it can actually cause a lot of confusion later on.
Oh, really?
Yeah. A much better way to conceptualize a variable is like a contact in your phone.
Okay, I'm listening.
You don't memorize your friend's 10-digit phone number, which is the actual raw data.
Mm-hmm.
Instead, you create a contact named Mom or Dave. That name is the variable. It's a label pointing to the data. When you call Dave, the phone knows exactly what data to fetch. In Python, you use variables to label data so you can call it up later without having to remember the raw data itself.
Oh, wow. That makes so much more sense. The variable is the name tag, not a physical container.
Precisely.
So once we know how to label data, levels 3 and 4 dive into what kind of data we are labeling.
Which is very important.
So level 3 is strings, which is basically text, and level 4 covers integers and floats, which are numbers. But let me stop you there.
Sure.
Why does the computer even care? To me, a number is a number and a word is a word. Why do we have to explicitly separate integers, which are whole numbers, from floats? What even is a float?
This is a perfect example of moving from shallow to deep understanding.
Okay.
To a human, the number 5 and the number 5.0 are practically the same thing.
Right, they mean the same thing to me.
But to a computer's memory and processor, they are entirely different beasts. An integer, a whole number, is very simple and takes up a predictable amount of memory. A float refers to a floating point number, basically a number with a decimal.
Because the decimal point can float anywhere between the digits, like 5.0 or 0.0005.
Exactly. And calculating where that decimal goes takes significantly more processing power and a completely different kind of memory allocation under the hood.
Oh, I see.
If the computer doesn't know whether it's looking at text, a simple whole number, or a complex decimal, it just doesn't know how to physically allocate its memory to store it, or what rules apply to it.
Which perfectly sets up the next grouping I'm seeing here, which is phase 3, manipulating that data.
Yes.
Level 7 introduces basic arithmetic, and level 8 introduces type conversion. And from what I understand, type conversion is where a lot of beginners completely tear their hair out.
It is a massive stumbling block. Type conversion is essentially learning how to change data from one type to another, like turning text into an integer.
But wait, if I use the input command we talked about earlier, and I ask the user for their age, and they type the number 25, it's already a number. Why would I need to convert it?
Because input always, by default, reads whatever the user types as a string.
Seriously?
Yes. It reads it as text. It doesn't see the mathematical value of 25. It sees the text character followed by the text character 5.
So if I try to write a program that takes their age and adds 1 to it to find out how old they'll be next year?
The program will crash.
Oh, wow.
Because you are asking Python to take a word and perform mathematics on it. To the computer, adding 1 to the text 25 makes as much sense as asking it to multiply the word banana by the number 5.
And banana times 5.
It just throws an error.
Right.
So type conversion is the vital skill of telling Python, take this text string 25 and translate it into the integer 25 so we can actually do math with it.
That is exactly the kind of under-the-hood logic that goes missing in those shallow tutorials.
It really is.
If nobody explains why the input defaults to a string, you just sit there staring at an error message, feeling completely stupid, when really the computer is just following strict rules about memory types.
And understanding those strict rules is what separates someone who guesses at code from someone who actually writes it. Which brings us to phase 4 of the meta rules of coding.
Okay, let's look at those.
Level 5 introduces comments, and level 9 tackles indentation, naming, and syntax mistakes.
I want to push back on level 5 for a second, actually.
Talk for it.
The source says comments are how programmers explain code to themselves. But if the computer completely ignores the comments when it runs the program, why dedicate an entire level to it so early on? Isn't that just extra typing?
It seems like extra typing right up until you step away from your code for 3 days, come back, and realize you have absolutely no idea what you were trying to build.
Okay, fair point.
We have to remember that code is written for humans first and machines second. Comments are the breadcrumbs of logic you leave behind. You are explaining your intent.
So you're writing notes to your future self.
Exactly. If you don't build the habit of documenting your logic early, your code will become an unreadable mess, even to yourself.
That makes total sense, and that ties directly into level 9, which is indentation and formatting. I know in some programming languages, like the source, list this as the final core review plus a mini project where you bring everything together into a real functional piece of beginner software. But I have to say, looking at modern coding boot camps and YouTube tutorials, they all promise that you will build an app on day 1.
They do say that. Yeah.
Holding off on a project until level 10 feels almost counterintuitive to the current tech culture. Why is this slower approach actually better for the listener?
Well, that modern rush is exactly why so many people fail to retain what they learn. Rushing to build a complex app on day 1 inevitably leads to copying and pasting code blocks that you do not actually understand.
You're just a typist again.
Exactly. The source makes a brilliant distinction here. Most beginners try to learn fast by jumping straight to advanced topics, and they end up moving fast through confusion.
Fast through confusion.
Yeah.
Wow.
Yeah.
That perfectly captures the feeling of finishing a 45-minute tutorial, having a working game on your screen, and knowing deep down you couldn't recreate a single line of it on your own if your life depended on it.
Because you didn't learn how to build it. You learned how to transcribe it.
Right.
And rushing through confusion leads to a weak structural foundation. It guarantees more complex mistakes later, and it ensures total paralysis when topics inevitably get harder. This 10-level system is entirely about moving fast through clarity.
Moving fast through clarity. So by intentionally slowing down at the start, making sure you deeply understand floats and type conversion and strings, you are actually massively speeding up your long-term progress.
Precisely. By moving fast through clarity, you make far fewer syntax and logic mistakes down the road. The script notes when you finally reach more complex topics later, things like conditional statements, loops, and larger projects, everything will feel profoundly easier.
Because you aren't fighting the basic syntax anymore.
Exactly. Building deep basics now literally saves you months of frustrating confusion later.
That makes total sense. Okay, so mapping out the 10 steps is great. We see the logic of the progression, but it clearly isn't enough to just read about them.
No, definitely not.
It's how you engage with those steps that actually transforms you. The source outlines a very specific learning loop for this training in Section 4.
The methodology within each level is highly intentional. The author designed it to be simple, deep, step-by-step, and completely practice-based. You don't just read theory.
Right, the loop goes like this. In every single level, you get a brief, clear explanation of the concept. Then you get some simple examples to anchor that concept in reality. And then crucially, you get practice exercises and a challenge exercise.
You're actively training your brain.
Yeah, coding is not learned by watching a screen. It is learned by seeing the logic, trying it yourself, making inevitable mistakes, fixing those mistakes, and building real confidence from that fiction.
And that active training loop is what facilitates the ultimate mindset shift we talked about at the beginning. A real programmer does not just type code. A real programmer learns how to ask the right questions about the code they are looking at.
So, what kind of questions should the listener be asking themselves as they go through these levels?
Well, instead of just asking, did it work?
Hmm.
You start asking things like, what is this specific line actually doing under the hood?
Okay.
Why is it written this way and not another way? What type of data is it, a string, an integer, a float, am I working with right now?
Right. Checking your types.
Exactly. Or, why is Python giving me this specific error message? And what is it trying to tell me about my logic? How do I think through this problem step by step before I even touch the keyboard?
So, what does this all mean for you, the listener? It means the ultimate goal of this entire journey isn't just about memorizing Python syntax. Syntax is just a tool, and honestly, syntax changes over time.
It sure does.
The real goal is building your programmer brain. It is about changing the way you perceive the information on your screen. We want to take code, which starts out as this mysterious, intimidating, fear inducing wall of text, and transition it into pure, understandable logic.
It is entirely about removing the illusion of magic from technology.
Yes, the magic.
When you don't understand how something works, it feels like magic. And magic is inherently intimidating because you can't control it. You can only observe it.
That's a great way to put it.
But when you break it down into these 10 logical, transparent levels, you realize there is no magic happening inside the machine. It is just logic.
Mhm.
And logic is something anyone can master if it is explained clearly and patiently.
And that brings us to our wrap up. If you are listening to this right now and you are a complete, absolute beginner who has never written a line of code in your life,
Which is perfectly fine.
absolutely. Or even if you are someone who started coding a while ago, but you still feel like your foundation is a little shaky and you find yourself guessing at solutions more often than knowing them, this journey is specifically designed for you. We are going to build your Python foundation the absolute right way,
We're going to build it level by level, concept by concept, practice by practice.
in a way that is deep, easy, simple, fast, and most importantly, actually understandable. We want you to feel the thrill of finally getting it. We are so excited for you to take this journey. So, to echo the rallying cry from the very source material we've been unpacking today, welcome to Python Basic Syntax in 10 levels. Let's start with level 1.